Good afternoon. This is Professor Parker, live from our office at Cheney University, and welcome to All This Math. Today we're going to do some work with simplifying radicals. So the first one, we have the square root of 6 times the quantity, because we don't say parentheses, this is a quantity, right? This information inside the parentheses is referred to as a quantity, right? So we have root 7, or the square root of 7, plus 4 root 6, or 4 times the square root of 6. Now, when we see a term outside of a set of parentheses, we automatically should think about the distributive property. And we should think about distributing that term outside to everything inside. So that means I also need to think about what can I actually multiply together. This is a square root, and this is a square root, so they can be multiplied together. This is a square root, and this is a square root, so they can be multiplied together, right? But what I can't do is, I can't do the square root of 6 times this 4 and get the square root of 24, because this is a square root, and this is not a square root, all right? But square roots can be multiplied by other square roots. So this is how it's gonna look, right? This root 6 gets multiplied by root 7. So that gives me the square root of, and you'll notice I keep saying root or square root of, those are interchangeable. Those terms basically mean the same thing, right? So I got root 6 times root 7, that's the root of 42, all right? And then I'm gonna do the root 6 times 4 root 6, which is plus 4 times the root of 36, right? All right, now my next thing is, I wanna see if I can simplify. I need to see if I can simplify. Can I simplify the square root of 42? Now, that doesn't mean can I put it in a calculator and break it down to a decimal? No, that's not what I'm talking about. What I'm talking about is there a factor of 42 that is a perfect square whereby I could pull that perfect square out of the radical sign? And there's no factor of 42 that's a perfect square. 42 has factors like 42, 1, 7 and 6, 14 and 3. None of those numbers are perfect squares, all right? So I'm gonna leave the square root of 42 alone, but then I'm gonna come down here, so I'm gonna write it over, root 42, but then I look over here and I say, oh, that 36 is a perfect square anyway. So actually I can take the square root of 36 and that's gonna just become plain 6. Now, one mistake that I wanna point out that a lot of students make is they take the square root of something, in this case it might be the square root of 36, and they'll simplify it to the square root of 6. It's not the square root of 6, it's just plain 6. That's all it is. It's just plain 6. The square root of 36 is just plain 6. So now we got 4, there was a 4 already outside, and now we got a 6 outside. So then you might be thinking, well, what are we supposed to do with that 4 and that 6? We multiply them together, because remember, 4 root 36 really meant 4 times root 36. And now I'm saying that the root of 36 is the same thing as 6. So really I'm multiplying, instead of 4 by root 36, I multiply 4 by 6. So I'm saying 4 times 6, and I know that that's 24, all right? Now again, I have to stop right here because I can't add these together because these aren't like terms. So one thing you're not gonna do is, you're not gonna add 42 and 24 and make that the square root of 66. That's what you're not gonna do, because that would be wrong. So this is actually the simplified form of this expression, root 42 plus 24. You might want to change the order around. Maybe you put the non-radical term in front, make that first 24 plus root 42, but that's a stylistic difference. It really doesn't matter. So this is the final answer to this one. Now, look at number 2. 1/3 times the square root of 72. So I want to simplify that square root of 72 if I can. So what I'm thinking about is, again, first of all, these are the questions you have to ask yourself when you're approaching problems like this. Is that radicand, and this number, 72, is called a radicand. So put that in your notes. The radicand is the number inside the radical sign. It's called a radicand, all right? R-A-D-I-C and. R-A-D-I-C-A-N-D. Is it a perfect square? No, it's not. There's no whole number that you can multiply by itself that will equal 72. So 72 is not a perfect square. 81 is a perfect square, 64 is a perfect square. 72 is in between 64 and 81, so we know that 72 can't be a perfect square. All right, but then the next question is, does 72 have a factor that is a perfect square? And if so, what is the biggest one? Because it might have multiple factors that are perfect squares, right? I happen to know that 4 is a factor of 72, and 4 is a perfect square. But 4 is not the biggest perfect square that's a factor of 72. And it matters to pick the biggest perfect square factor, because if we don't pick the biggest one, we're gonna have to repeat that step over again. And we don't want to repeat the step over again. We just want to do it one time and be one and done. So the biggest perfect square factor of 72 that some people might forget about is 36. Because 36 times 2 equals 72. So what I do is I rewrite the 1/3, and I change this to 36 times 2, because 72 is equivalent to 36 times 2, right? So now I'm saying, okay, I got 36 right there. So now what I'm going to do is I'm going to pull the 36 out, and this is how I recommend you write it on your papers when you do these problems, when you get them for homework or classwork. You pull the 36 out, that turns into a 6, because the square root of 36 is 6, right? So now I bring the 1/3 down, and now I got a 6, and the 2 can't come out. The 2 stays inside the radical sign. Or you can look at that, think of that as a house. The 2 can't come outside. The 2 got to stay in the house, right? But this 1/3 and this 6, I can multiply those together. So what's 1/3 times 6? 1/3 times 6 is 1/3 of 6, which is just 2. Or you could think of it as 1/3 times 6, which is 1/3 times 6 over 1. 1 times 6 is 6. 6 over 3, because 3 times that invisible 1 underneath of the 6. 6 over 3 is also 2, right? So now this becomes 2. These two numbers, the product of these two numbers is 2. And I got 2 root 2. And that's my final answer to that. So the simplified version of 1/3 root 72 is just 2 root 2. And the simplified version of this expression is root 42 plus 24. All right? Thank you for tuning in. Hope you learned something new, and I hope this helps you when you're confronted with problems like these. Please go to the YouTube channel, like, subscribe, tell a friend to tell a friend. This is Professor Parker.